Alright, hi guys, hope everyone's doing well. So I figured I would do a little bit of a different video today. Yes, I'm actually in it. This is great. But anyway, what I wanted to do was one where we are given grams of each one of our reactants. So in this example we have sulfuric acid and we have boron chloride. And what we're going to do is we are going to take both of these reactants. We are going to first balance the equation and then figure out which one of these is our limiting. And then lastly, given the problem, we are going to figure out how much of one of these two products is formed. So obviously we got to start off by balancing our chemical equation. We'll start off with H on this side. We have 2. SO4s, that's our polyatomic of sulfate, we have 1. Borons, we have 1. And chlorines, we have 3. All right, over on this side, hydrogens, we have 1. Sulfates, we have 3. Borons, we have 2. And lastly, chlorines, we have 1. All right, so let's start off with the sulfates. It's probably the easiest one to do. I have 3 on this side, 1 on this side, so I'm going to put a 3 here. That is going to make our sulfates become 3, and then for hydrogen, 3 times 2 is going to be 6. So now we're good with our sulfates, but we kind of knocked the hydrogens even more out of whack than what they were. So I'm going to put a 6 in front of here, because we have 1 hydrogen, 6 times 1 is 6, and chlorine, that also is going to take it to 6. And then lastly, if we put a 2 in front of boron, we get 2 there, and we get a 6 because 2 times 3 is 6. So we're all balanced now, and that's all we need for that. So let me erase all of our work there. Cool. So now we have our balanced chemical equation. Our next step we are going to do is we are given 100 grams of each reactant. And what we're going to do is we're going to take both of these reactants and we're going to find out which one is going to be limiting. So let's start off. We are given 100 grams of H2SO4. And we're also given 100 grams of BCl3. We are going to convert both of these to moles first. So what I did was I already looked them up on the periodic table, guys, and I found the molar mass of sulfuric acid was 98.09 grams per mole. And then for boron chloride, I found it to be 117.16 grams per mole. After that, we got to determine, all right, what do we want to be in? Do we want to be in moles of BCl3 or do we want to be in moles of H2SO4? It doesn't matter which one you pick, just like in my last video. I'm going to choose to have both of them go to BCl3. So this one's already done. I just have to put in my calculator 100 divided by 117.16, and I get 0.85 moles. Okay. BCl3. So there's one part of it. The second part, now this one right now is in moles of H2SO4. We want them to be the same, so we are going to do a mole ratio. Now we already got grams of H2SO4 to cancel out. We need to get moles of H2SO4 to cancel out. So what we're going to do is we are going to put moles of H2SO4 on the bottom. And then on top is where we want to get to, so it's going to be moles of BCl3. But we don't have any numbers in here yet, and that's where we have our balanced chemical equation to help give us those numbers. So what number is in front of H2SO4? It's a 3, so we're going to put a 3 there. And what number is in front of BCl3? It is a 2. So now we have all that done, and we could put in our calculator 100 times 2 divided by 98.09 times 3, and we get 0.68 moles of BCl3. So we did all this to figure out which one is limiting, and we haven't really went over which one's limiting yet, but we got the numbers to determine that. So on the top one, it's 0.68, bottom one is 0.85. We're going to pick which one is lower, which is obviously our top one here. And what we're going to do is we are going to determine which compound in our reactants is that one associated with. So for this one, the 0.68 is associated with our H2SO4. So that's everything we did there just to find out H2SO4 is limiting. From here on out, we don't care anymore about the BCl3 because we're going to have an excess amount of it. So we're going to use our H2SO4. So from the beginning, we were given 100 grams of H2SO4. And we are going to convert that to moles, just like we did in the last one. So we're going to have 4 of these steps here, because what we're going to do is we want to find out how much B2SO4 is produced. So we're going to do a mole ratio just like we did on the last one. So we're going to have moles of H2SO4 on the bottom. And then on top, we are going to have what we're trying to get to, which is moles of B2SO4. Plug in those numbers just like we did last time, which I just totally lost my balance equation, which is lovely. I'm going to go back here, because I can't remember the number. Okay, so we had nothing in front of here, but in front of H2SO4 we had a 3. So let me get all my stuff back here. Oh, look, it is magic, yes. Right. Okay, so we are going to have a 1 in front of here, because we had a 1 here, nothing there. And then in front of our H2SO4 we had a 3, so that's going to go down there. So right now we got rid of grams of H2SO4, that's gone. We now got rid of moles of H2SO4. And then lastly, we got to get, because we want to calculate the amount, which is going to be in grams, we're going to have moles of boron sulfate at the bottom. And then on top, we're going to have grams of boron sulfate. So I already did our molar mass, which is 309.8. And then lastly, we just got to put this in our calculator, so it'd be 100 times 309.8 divided by 98.09 times 3. And we find out that if this reaction occurs with the reactants of both having 100 grams, we are going to have sulfuric acid as our limiting reactant. And if that's the case, we will have 105.28 grams of boron sulfate produced. All right. So hopefully this helped you guys out a little bit. We're going to be doing a little bit more work on this, but if you get this, everything else should be pretty easy. So, all right, guys, I'll see you in a little bit. Have a good day.